Thank you. Thank you. Welcome to our first math cast in our sequences and series chapter. Today's topic, number patterns. We're going to go back to a topic that is pretty fundamental in mathematics, the study of order. Now, organizing elements into a certain order actually makes things quite a bit easier for us to understand. And we see this in our daily lives all the time. For example, there is what we call the typical teenager room. And I know this because I live with two teenagers. And I wouldn't classify this room exactly as order. I would call this room a little more like random chaos. Now, in reality, we know that if the room was sort of cleaned up, it could look something like this, that we would then classify as an ordered or an organized room. When you get to high school, you start in grade 9 and do some basic mathematics, some BEDMAS and so on. And you continue through high school. When you are in grade 12, we begin things like calculus. Okay. We do it in that certain order. Okay. We don't do calculus in grade 9, and we don't do a lot of BEDMAS in grade 12. In sports, in baseball, there's typically a batting order. There's the person who bats first, the person who bats second, third, fourth, and so on. Maybe the person who bats first is good on getting base every time, and the person who bats fourth is good at hitting home runs, so they can sort of cash in all these people who are on base. There's alphabetical order. And you can imagine how difficult memorizing the alphabet would have been without an order. Someone could say to you, okay, name all the letters in the alphabet. And you could be, okay, there's J, there's a Q, a B, I suppose, there's an A, X, did I say J? Wait, let me start again. Obviously, having an order, A, B, C, D, E, F, G, has allowed us to acquire some knowledge. Of course, we've seen the order in mathematics in terms of BEDMAS, and that helps us quite a bit work through our order of operations. And for us, we're going to start with numbers that are in a certain order. A list of numbers where there is a pattern is called a sequence. So there needs to be a pattern. There needs to be some order. It's not a random list of numbers. It's a specific list. Now, each element in the sequence is called a term. So for this sequence, we start with the first term, which is 3, then the second term, which is 5, and so on. The third term is 7, the fourth term is 9. And these 3 dots are actually important because those 3 dots means that it goes forever. Okay, a sequence doesn't just stop at the last number. These dots tell us that we keep continuing along this same pattern. So look at this sequence and think to yourself, what would the next number be? We see we are adding 2 each time. So the next number would, of course, be 11. How about this one? Subtracting 5 each time. So the next number would be -9. This one. We are dividing by 2, or we are multiplying by a half, or 0.5. So the next one, of course, would be 1/2. How about here? We are timesing by 2 each time. So the next one would be 64. Pause the mathcast and try these on your own. Okay, welcome back. The correct answers here, we're adding 7 each time. So this would become 45. Here we are adding 6 each time. So this would be 32. Here, this one's pretty easy. We're adding 15 each time. So this one would be 80. Here we are subtracting 5 each time. So this would be 30. And this one we are adding 37 each time. So the answer would be, for the next one, 171. Okay, take a look in your books at page 36, questions 1 to 5.